learned two rules this morning on powers. The first rule is called the multiplication rule. So the multiplication rule of powers. So let's see. If I gave you 2 cubed times 2 squared, all you got to do is write now. This is the base, this is the base. That's the index, that's the index. And if I told you to multiply, all you got to do is write down the base one time and add the indices 3 plus 3, and the final answer will be 2 to the 6. Let's do another example. 5 squared times 5 cubed. So according to the multiplication rule of powers, write down the base once and add the indices 2 plus 3. So the final answer will be 5 to the 5. Now, very important when it comes to indices, whether you're multiplying or whether you're dividing, the rule operates or the rule works only if the bases are exactly the same. So you can only use the multiplication rule of powers if the bases are exactly the same. The bases are exactly the same, so you can use this rule. Let's do another example. X squared times x cubed. You remember that asterisk also means multiply. So you write down the base, which happens to be x this time, and 2 plus 3, 5. Number 4, m squared times m. Now you recall that the index here is understood to be 1. So don't say there's no index. You've got to remember that it is understood to be 1. So there it is now. And the final answer is 2 plus 1. That gives you m to the 3. So by studying these examples, we can now summarize the multiplication rule of powers. So the multiplication rule of powers is write down the common base once. I'm emphasizing the word once, and add the indices. So that's the multiplication rule for powers. Write down the common base once and add the indices. Now common in maths here, common means same. So you see, the bases must be exactly the same. The bases must be exactly the same. But we don't say same in maths, we say the bases must be common. So that's the multiplication rule. So if I ask you what is the multiplication rule of powers, you just tell me, write down the common base once and add the indices. If I give you an example, then you do it like this. You don't have to show this step. You can do it mentally. You can go and try the answer like this straight. But I've just done it to show you step by step. So I'll just do one more example. M to the 4 times m to the 5 times m squared. It doesn't matter how many times the power is there. You write down the common base, m, and add the indices. So 4 plus 5 is 9. But I'm just going to do it step by step to show it to you. And that's 4 plus 5, 9 plus 2, 11. Now look at number 6. M squared times n cubed. Here the rule does not apply. You can't do nothing here. You just leave it like that. The rule does not apply because the bases are not the same. So you must be careful. The rule can only work if the bases are the same. In this example, the base is not the same. This is m, that is n. So the rule does not apply. Alright, so that brings us to the end of multiplication rule. Now we move on to division rule. Now I'm just going to give you the rule, and your teacher can explain to you why the rule works, etc. Let's take an example. 8 squared divided by 8. Well, the one is understood. According to the division rule, write down the base one time and subtract the indices. So the answer will be 8. Now, alright, let me just demonstrate that it is true. So the division rule says, write down the common base once, subtract the indices, and so your final answer is 8 to the 1, which is 8. Well, let's see if it is true. What is 8 squared? 8 squared is 64. 8 squared is divided by 8. So that means this is really 64 divided by 8. Now you can put that in the calculator and you'll see you get the final answer, 8. So whatever we're showing you here is true, as is demonstrated by this example. So let's do another example. M cubed divided by m squared. You write down the base once, subtract the indices, and 3 minus 2 gives you 1. Number 3. Now here's a famous catch. M cubed divided by m to the minus 2. Now you've got to be very careful with an example like this. There's your base. Bases are common, you can write it down. It is 3 minus 2. So you've got to make sure, to get it right, make sure that you write this step down like this. M is equal to 3 minus 2. So that's m, there's your 3. Now minus times minus gives you plus. 3 plus 2, the final answer is m to the 5. I'm just going to do another example like that. M to the 4 divided by m to the minus 3. So you write down the base once, subtract the indices, 4 minus 3. So it's always wise to write this index in a bracket. It is better to write this index in a bracket so that you will get it right. And then you've got m 4 minus times minus plus 3, final answer m to the 7. So let's see what is the division rule. So the division rule will be, write down the common base once and subtract. Subtract means minus, and subtract the indices. Remember, once again, if I ask you what is the division rule for powers, you just tell me, write down the common base once and subtract the indices. First, you've got to learn the rule off like that. Then you learn to apply it in examples. So if I meet you walking down the road and I tell you, hello, how are you, and ask you, what is the multiplication rule of powers? You should immediately say, write down the common base once and add the indices. If I ask you what is the division rule, you should tell me, write down the common base once and subtract the indices. So once we know these two rules, you'll be able to do some multiplication and division in algebra. Alright, let's move on to a little exercise now. take the first example. M to the 5 times M to the 2. So when you read this question, you'll say, well, this is multiplication, write down the common base once, add the indices, and the final answer is M to the 7. Take example 2. M to the 5 divided by M squared. Now you'll say, well, write down the common base once. This is division, therefore I must subtract the indices. 5 minus 2, and I'll get M to the 3. Number 3, A times A. Well, when you look at this example, you'll say, well, the bases are the same. Write down A, and the index is understood to be 1. The index is understood to be 1. So this is 1 plus 1, which is A squared. Number 4, A squared times B squared. Well, when you look at this example, you'll say bases are not same. Bases not same. Right? So rule does not apply. See, the bases are not the same, so the rule does not apply. Alright, so that's simply how you do. Now, let's suppose you have more than 2 bases. M to the 5 times M squared times M cubed. Well, you're just going to add all. So you get M to the 5 plus 2 plus 3, and that's M to the 10. Number 6, M to the 5 divided by M to the minus 3. So, you'll see division, write on the common base once, then 5 minus 3, which is M, there's your 5. Now minus times minus gives you plus, so it's M to the 8. We will stop here for a while. Alright, now from number 7 onwards, I'm going to bring in one extra step. Now watch carefully. Now you got 5x squared times, remember this is a times now, or let me make it asterisk is better. 5x squared times 2x cubed. Now I brought in one extra step, there's some numbers here. Well, you know 5 times 2 is 10, so that's not hard. You just write down the 10. And then when you look at the powers, the bases are the same. Write down x, 2 plus 3, because you're multiplying. And the final answer will be 10x to the 5. Let's do another example. 7m cubed times 2m squared. So, the number times the number, 7 times 2, 14. Then write down the common base once, and then add the indices 3 plus 2, and now I can write it down 5 one time. Number 9, now be careful, minus 2m squared times 3m to the 4. Now you've got a minus 2 times 3. So remember your integer rules. Minus 2 times 3 will give you minus 6. And then for the powers, write down the common base m and add the indices 4 plus 2, 6. Let's do another. Now let's do a division example. 8a4 divided by 2a squared. Well, now you're dividing. So 8 divided by 2 will give you 4. A4, a squared. Write down a once, the bases are the same. Subtract 4 minus 2. 4 minus 2, so you get 4a squared. Now, the example can also be written like this. 10m to the 4 divided by 5m squared. We're dividing, you see. So 10 divided by 5 will give you 2. And then for the powers, write down the base m and subtract the indices. 4 minus 2, 2. Now, in number 12, we're going to do two bases. Now you've got m4 n cubed divided by m squared n squared. Now you've got two bases. So all you do is, for the m, you write the base once. For the n, you write the base once. Then for the m, it will be 4 minus 2, which will give you 2. Then for the n's, it will be 3 minus 2, which will give you 1. So I'm going to do a few more examples on the other side, so that we get this thing nice and clear in our mind. Number 13, I can give you two powers to multiply at one time. Then you say, right, no problem, there's an A here and a B, there's an A here and a B, so for the A's, I'll write A, for the B's, I'll write B. Now, for the A, it will be 3 plus 5. 3 plus 5, that gives me 8. For the B, there's a 2 here and a 1 that is understood. So 2 plus 1, 3. Now, let me give you one. You will say, the teacher trapped us with this, but we're not trapping you. You just have to know your rules. So now you got A, B, C, A, B. So you feel you're trapped. No, you're not trapped. There are three bases here. Right? So for the A's, you write down A. For the B's, you write down B. And there's only one C here, so you will just write down the C squared straight away, because there's nothing else over here. Now for the A, you multiply, so it will be 2 plus 2, 4. For the B's, it will be 3 plus 2, which is 5. Right, let's take number 15. A squared B squared times m squared n squared. Now clearly all the bases are different. You cannot add these indices, but you can write them next to one another like this. A, B, M, N. You are allowed to write them next to one another like that, and just give them their own indices, where all of them happen to be squared. Right? So we can't add the indices here because the bases are different. So all the bases are written down again, and each one's index remains with it. Alright, so let us see. We've done some multiplication, we've done some division, and we've done some examples with numbers. Alright, so let's do one final one. 16, 50 m squared divided by 25 m to the 5. Now you'll see what happens here. 50 divided by 25 will give you 2. For the m's, you'll write down m. Now you're subtracting 2 minus 5. That 2 subtracting this 5. And the final answer will be 2m to the minus 3. Now that's one answer. But this example can be done in another way. Now to avoid having this minus sign in the answer, what you can do is you study this example carefully and you see where the index is bigger. Clearly the index is bigger in the denominator. So to avoid the minus sign in the answer, you will subtract where the index is bigger. So let me redo this example. Now there's nothing wrong with that answer, but another way to do this so that you don't have a minus sign in the answer is, you'll say, right, 25 divided into 25 one time. 25 divided into 50 two times. So we finished with that. Then when you study this too, you find the index is bigger here. Therefore, you will subtract where the index is bigger. So I'll do the subtraction down here in the denominator. So it will be 5 minus 2. This 5 minus that 2 there. So the final answer will be 2 over 1. That's 2 over 1. There's your m. 5 minus 2 gives you 3. Now these two answers are exactly the same. That answer and this answer are exactly the same. It doesn't matter, it's got a minus 3 there. So that brings us to another important idea about powers, about negative indices, but we shall do that in another lesson. But for the time being, to avoid that minus sign, we're saying study the powers carefully. If the power is bigger in the denominator, do the subtraction in the denominator so that you don't end up with a minus sign. Alright, so I'm sure you've got an idea on how to apply the multiplication and division rules together with some numbers involved in it, and we'll now give you an exercise to complete. Alright, we're looking at exercise 7 based on powers, exponents, indices. Number 1, a squared times a to the 4. Number 2, m cubed or m to the 3 divided by m to the 2. Number 3, x squared times x. Number 4, n to the 5 divided by n to the 5. Number 5, n to the 5 divided by n. Number 6, x squared times y squared times x cubed times y to the 4. Number 7. Number 7, a times b times a squared times b squared. Number 8, x squared times y squared times y to the 4 times x squared times x to the 3. Number 9, a squared times b times c times a squared again. Number 10, 2a squared times 3a cubed. Number 11, 8m cubed divided by 2m squared. Number 12, minus 3m times plus 2m squared. Number 13, minus 10 cubed divided by minus 2x squared. Number 14, x times y times z. Number 15, 2 times a times b times c. Number 16, 5 to the 2 times 5 to the 3. Number 17, 2 squared times 3 squared times 2 cubed times 3 to the 4. Number 18, 2 squared a squared b times 2 cubed a b cubed. Number 19, minus 20a squared divided by minus 4. Number 20, minus 6 x squared y squared divided by plus 2 xy. Good, so here we are, solutions. Another word for solutions is answers, answers to exercise 7. Number 1, you had a squared times a to the 4. So right on the base, add the indices and you get a to the 6. Number 2, m cubed divided by m squared. Write down the base. This is division, so you have to subtract the indices. So m to the 1. Number 3, x squared times x. Well, the 1 is understood, so it's x to the 2 plus 1, which gives you x to the 3. There's no need for you to show this working, but I am showing it so that people understand exactly how we got the answers. Number 4, n to the 5 divided by n to the 5. So there's your n, 5 minus 5. Now, very important, 5 minus 5, the answer is 0. You must write down that 0. You cannot leave it out. So I'll repeat, n to the 5 minus 5. 5 minus 5 is 0. You must write down that 0. And while we're here, now n to the 0 is equal to 1. Any number or any letter to the 0 is equal to 1. I'll do a little reminder for you at the end of this exercise about that. Number 5, n to the 5 divided by n. Well, once again, that's n to the 5 division, so I have to subtract. Now here 1 is understood, so it's 5 minus 1, so it's n to the 4. Number 6, you've got x squared times y squared times y to the 4 times x squared times x cubed. So you've got different bases here. So there's x and there's y. So you write down x and you write down the y. Now you add for the x's. 2 plus 2, 4 plus 3, 7. So I just write the final answer. I'll repeat. 2 plus 2, 4 plus 3, 7. When it comes to y, you got 2 plus 4 giving you 6. So that's your answer. Number 7, you got a times b times a squared times b squared. Well, you got two bases here. You got a and you got b. You write them next to one another like that. And then you add the indices. There's a 1 here that's understood. 1 plus 2 gives me 3. There's a 1 here that's understood. 1 plus this 2 gives me 3. Number 8, x squared times y squared times y to the 4 times x squared times x cubed. So you got two bases here, x and y. So write down the x, write down the y. Then add for the x's, only the x's now because we're dealing with x. 2 plus 2, 4 plus 3, 7. Then we do the y's. 2 plus 4, 6. So that's your answer. Number 9, a squared times b times c times a squared. Now this time we got a number of bases here. We got a, we got b, we got c. So you write down all three bases, a, b, c, next to one another. Then if you look at a, you got a squared here and you got a squared there. So you can multiply these two. So it will be 2 plus 2, 4. The b, the index is 1, so it will be 1. The c, the index is 1, so it's 1. And that's the final answer. Right? We cannot add those indices up because those bases are all different. Number 10. 2a squared times 3a cubed. Now, in addition to the powers, you got numbers. Well, the numbers is straightforward. 2 times 3 is 6. Then you got the base a, write it down. 2 plus 3, because we're multiplying, we have to add 2 plus 3, 5. Alright, I'll do the rest of the answers on the other side. So that's your answers for number 1 to 10. Number 11, 8m cubed divided by 2m squared. Well, now you have numbers and you have powers. So let's do the numbers first. 8 divided by 2 is 4. Then m cubed divided by m squared, write down m. 3 minus 2 because we are dividing. Number 12. Minus 3m squared in bracket plus 2m squared in bracket. Now, the bracket means we're multiplying. The brackets means we're multiplying. So, minus 3 times plus 2 will give you minus 6. Remember your integer rules. Minus times a plus is minus. 3 times 2 is 6. Now, for the powers, m squared, write down m. And because we're multiplying, we're going to add the indices. 2 plus 2, 4. Number 13. Minus 10x cubed divided by minus 2x squared. Right, we're dividing. So we've got numbers. Minus 10 divided by minus 2. A minus divided by minus gives you a plus. 10 divided by 2 gives you 5. X cubed, x squared, write down x. 3 minus 2 gives you 1. So now what's happening? We are applying integer rules for the signs. Minus divided by minus is plus. 10 divided by 2 is 5. So here we're using integer rules. Then on this 2, we're using power rules. Number 14. X times y times z. Well, we've got 3 different bases. We just write them down next to one another. No space in between. And then, well, the indices are all understood to be 1, and I don't have to write the 1. So I can write the answer like that, or I can write the answer like this. Both answers are acceptable. Number 15. 2 times A times B times C. Well, all the bases are different, and this is 2. So there's nothing else to be multiplied. There's your 2. A, B, C will be just written next to one another, and that's the end of the story. Because we can't add those indices. The bases are all different. Number 16. 5 squared times 5 cubed. Now remember, the base can be a number or a letter. This time the base is a number, so the base is 5. You write down 5 once. And then you add the indices, 2 plus 3, 5. So remember, the base can be a letter or the base can be a number. Number 17. 2 squared times 3 squared times 2 cubed times 3 to the 4. Now, we've got 2 different types of bases. We've got a base 2, and you have to write a multiplication sign now because you're dealing with numbers. When you deal with letters, you can just leave it like that next to one another. But when you deal with numbers, you have to put a multiplication sign in between them. Now if I take 2, the base 2, I'll add the indices. 2 plus 3 gives me 5. Then if I take the bases 3, I'll add their indices up. 2 plus 4 gives me 6. Now this will remain like this. You can't do anything more because now the bases are different here. So it will just stay like that. Because remember the rule, add the indices works only if the bases are the same. Now the base is 2. Here the base is 3. So you can't add those indices and you just leave it like that. That's the end of the answer there. Number 18. 2a squared b squared times 2 cubed. 2a squared. That's your question. 2 squared a squared b times 2 cubed a 2 cubed ab cubed. Right, now if you watch carefully, you've got three different bases now. You've got the base 2, you've got the base a, you've got the base b. Now for the base 2, there's an index 2 here and the index 3 there. So we add that up, 2 and 3, 5. Now for the base a, you've got 2 here and you've got the 1 that is understood. So 2 and 1, 3. Now for b, you've got 3 there and here the 1 is understood. So it's 1 plus 3, 4. So when there's numbers and letters like this, you can just write them next to one another. But if there's only numbers, you have to put the multiplication sign. Number 19, minus 20a squared divided by, you see the slash, this slash divided by minus 4 really means minus 20 a divided by minus 4. That's what it means. Now minus 20 divided by minus 4, minus divided by minus gives you plus. 20 divided by 4 gives you 5. Now there's only an a on the top, so the a just remains there like that. Or another student might say, look, this answer can also be written as 5a all over 1. Because that student can say 4 divides into 4, 1 time. 4 divides into 20, 5 times. Minus divided by minus gave us plus, and the a is on the top. So this answer could have been written like this or like that. And finally number 20, minus 6x squared y squared divided by 2xy. So let's write it like this. Minus 6x squared y squared divided by 2xy. Now watch. Plus divided by minus is minus. 2 divides into 6 3 times. So I can write the minus sign on the top, right? Plus divided by minus is minus. I can write the minus on top. I can write it anyway. I can write it on the top, in the middle, or in the bottom. But it's better to write it on top. Now x, remember the rule. When you got a numerator and a denominator, see where the index is bigger and subtract there. So both these indices are bigger on the top here. So it's better for me to subtract on top. So 2 divides into 2 one time, really speaking. 2 divides into 2 one time. 2 divides into 6 3 times. Now the indices are bigger here. So 2 minus that one gives me 1. 2 minus this one here gives me 1. And this final answer can be minus 3xy. That brings us to the end of exercise 7. I hope you did well there and got them all right. If you didn't, no need to get disappointed. Just go back, retry them. I always advise you to redo the whole exercise from start to finish, because the more you practice, the better for you. Alright, now we're moving on to another section, or at least another rule, still dealing with powers. So earlier on you learnt the multiplication rule. Number 1, the multiplication rule, where you added the indices. Then we did the division rule, where you subtracted the indices. Now we come to rule number 3, which is called power to power rule. Let's do a little demonstration first. Say you have 2 squared all cubed. Then this means that whatever is inside the bracket has to be multiplied 3 times by itself. In other words, 2 squared has to be multiplied by 2 squared has to be multiplied by 2 squared, because it is saying whatever is in the bracket is cubed. So, so whatever is here has to be multiplied by itself 3 times because it's cubed. Now if I work this answer out using the multiplication rule, it's 2 plus 2 plus 2, it's 2 to the 6. Now watch carefully. This is 2, there's the base. Now just watch the indices. There's 2 and there's 3. So because it's cubed, I have to write it 3 times. Then if I use the multiplication rule, I got 2 plus 2 plus 2, I got 6. But if you look carefully at this example again, and if you see that the answer ended up 6, and if you look here carefully, you realize that there is a shortcut. That you can just say, well, it is 2 to the 2 times 3, which is 2 to the 6. So this is called the power to power law. You see, there's a power here, and there's another power here. So power to power. If you got power to power, you just write down the base once, and then multiply the indices. So let's do another example. 3 to the 5 all squared. Well, this is a power to power. Just write down the base, take the indices and multiply it. So you get 3 to the 10. So that's your power to power rule, which says that, look, if you've got a power to a power, write down the base and multiply the indices. So what does the power to power rule says? Power to power rule. Write down the base and multiply the indices. All right. So let's do a few more examples. So if I had a squared all cubed, then this is a power to power. I'll just write down the base 1 time and multiply the indices 2 times 3, and I'll get a to the 6. Now, very important thing. If you have 2 powers inside, now you've got 2 powers inside and you've got a power outside. Well, you can think about this like rooms in a house. You want to send power to every room. So this power goes there and this power goes there. So it will be, write down the 2 bases. 2 times 2, 4. 3 times 2, 6. Alright, so I'll repeat that. You see, that power there goes to each power inside. So A, you write down A. B, you write down B. Now it will be 2 times 2, 4. 3 times 2, 6. Right, let's do another example. Now sometimes the powers can be above and below. Now, the power has to go there and there. So if you think about this like a house, there's an upstairs and downstairs. The power has to go upstairs and downstairs. So, on the top you got m 2 times 4. The downstairs you got n to the 3 times 4. So, there you got 2 times 4, 8. And here you got n 3 times 4, 12. So I'm going to do a few more examples on the board to make this clear. Alright, some more examples on power to power. Let's take an example like this. 2m squared n cubed all to the 4. So, well, if you have a problem remembering things, this is like 3 rooms in a house. We want to send the power to every room. Now remember, the 1 is understood here. So this is really 2 to the 1 times 4. Then you got m 2 times 4. Then you got n 3 times 4. Now there's no need for you to write that working like that. I'm doing it just to make it clear. So the final answer is 1 times 4, 4. Then you write m next to it. 2 times 4, 8. Then you got n, 3 times 4, 12. Let's do another example. Say you got 5m squared over a cubed. And all this is to the power 5. Then the power has to go every way. To the 5, to the 2, and downstairs 2. So, the final answer now, I'm not going to do every step, will be 5. There's a 1 here. 1 times 5 is 5. Then there's an m. 2 times 5, 10. That's upstairs. Now downstairs, you got an a. 3 times 5, 15. Alright. Now watch the next example very carefully. Now in this example, the 5 is all alone. Only the a squared is raised to a power. In other words, we only got power to power here. The 3 got nothing to do with the 5 because the 5 is outside the bracket. So the 5 just remains 5 like that. That power only affects this 2 here. So the final answer is a. 2 times 3, 6. Right, let's just do another example to make it clear. M squared into n cubed into 4. Now clearly that power is only affecting n cubed, not m squared. So m squared will be on its own here. Then you write down n, and 3 times 4 will give you 12. So in maths you must have good eyes. You must be able to see that that power is only affecting that. This power is only affecting this. Now let's do another example. M squared into a squared, b cubed, all squared. Well, now that is on its own, so that remains there. Now this 2 will go there and there. So you'll have a to the 2 times 2, 4, and b 3 times 2, 6. Alright, so I think we've done enough examples now on power to power, and you've got an idea how to do it. And we will now give you an exercise, and you will attempt the exercise, and after that come back to the DVD and we will give you the answers. Alright, so have some. Okay, before we move on to exercise 8, I need to explain something. You see, when a bracket is written like this one is called open bracket. And this one is called close bracket. So, if I say open bracket, then you'll write that. 5m squared, you'll write 5m squared. Close bracket, then you'll close bracket. Or to the 3, then you write the 3 like that. Let's take another example. If I tell you 5m, you'll write 5m. Open bracket, you'll open bracket. 3x squared, close bracket, you close bracket, all to the power 4, to the power 4. So open bracket means that, close bracket means that. So when I'm doing exercise 8, I'll be using the words open bracket and close bracket. So you need to understand what we mean by open bracket, what we mean by close bracket. Alright, so now we're going to move over to exercise 8. Exercise 8. Number 1, open bracket, 5 cubed, that means 5 to the 3, close bracket, all to the power 2. Number 2, open bracket, a squared, close bracket, to the power 5. Open bracket, b squared, close bracket, to the power 2. Number 4, open bracket, 2a squared, b squared, close bracket, 2. I mean to the power 2. Number 5, open bracket, minus 3a squared, b cubed, close bracket, to the power 3. Number 6, 2a, open bracket, 5m squared, close bracket, to the power 2. Number 7, minus 2a, open bracket, 5 squared, m squared, close bracket, to the index 2. Number 8, open bracket, 5m, close bracket, to the index 2. Open bracket, 3m, close bracket. Number 9, open bracket, 3ab, close bracket, to the index 2. Open bracket, ab, close bracket. Number 10, open bracket, 5a squared, close bracket, to the index 2. Open bracket, 2a cubed, close bracket, to the index 3. Right, answers to exercise 8. Number 1, you had 5 cubed or squared. So that will give you 5 to the 6. 3 times 2. We're using the power to power law. Then you had a squared, all to the 5. Write down a. 2 times 5, 10. Number 3, you had b squared, all squared. So there's your b. 2 times 2, 4. Number 4. Now when I'm writing number 4, this is how we talk. We say open bracket to a squared, b squared, close bracket, to the index 2. And sometimes what happens, instead of saying index 2, we also say power 2. So we talk like that, and it is now accepted. So although the right word for this is index or exponent, sometimes you'll say people say power 2. Well, it's fine. Alright, now this 2 goes on to each factor there. It goes on to each factor. So you'll get 2 squared, a, 2 times 2, 4. b, 2 times 2, 4. Number 5, open bracket, minus 3a squared b cubed, close bracket, to the index 3. I can say to the index 3 or I can say cubed. C-U-B-E-D. See, I can say index 3 or I can say cubed. So this will be